Hello, and welcome back to the Geranium tutorial. After you've learned how the tool works by watching this video, let's now learn how we can use it to analyze and answer real-world questions. In this video, we'll explore how it can be used as a lens to explore an area. We can take one of the priority areas of conservation, or PACs, as an example. So let's look at PAC 5 located in the Bering Sea. Here we'll see how geranium can be used to assess conservation concerns, understand risks for biodiversity, and identify specific areas and conservation and protection measures. First, let's begin by heading to the home page. In the Spatial Query tab, select ArcNet Priority Areas for Conservation, and in the Projection tab, select Bering Sea. On the map on the left, you can choose your PACs. We will select PAC 5, which is at the bottom of the map between Alaska and Russia. After selecting this, click on the Overview for PAC 5 Area button. This will bring up a summary of the conservation concern analysis for the selected area. This calculation can take a few seconds. The analysis shows us that the Bering Strait region is a very high conservation concern. So how can we tell this? The various graphs and stats in front of us indicate the level of conservation concern in various ways. For instance, in the bottom right panel, you can see that the concern indices are very high. The relative significant concern level for a given area of interest by planning units index, or RSCPU, is 465%, which tells us that the average significant concern level of planning units in the area is almost 5 times higher than the Arctic-wide average. The relative significant concern level for a given area of interest, or RSCAIO, another index, which is 23%, tells us that almost every fourth assessment of each conservation feature and industrial activity pair for each season of the year resulted in a significant level of concern, which again is higher than the Arctic average. Click on each index to read a full explanation of what they mean and how they are calculated. For more detailed information, you can refer to the Manual tab at the top of the page. Next, we look at the relative overall concern for a given conservation feature, or ROC-CF. This shows us how often each conservation feature is flagged for concern. The top CFs by ROC list on the right shows all the features with an ROC score above 50%. Here we can see that more than 20 features have a score of above 50%, which means that more than half of the assessments raise significant levels of concern. These features include species and habitats across multiple thematic groups ranging from polar bears, seabirds, to features showing the distribution of walrus and benthic features. This can be noted from the first digit of their numerical code, and by hovering over the number, you can see the name of the conservation feature. Let's now look at the top right panel of the Relative Overall Concern Level by Industrial Activity, or ROCIA. This graph ranks different industrial activities in descending order based on how much concern there is for biodiversity in the area of interest. As you hover your mouse over the bars, you can see the full name of each industrial activity. We see that there are many industrial activities, 18 out of 33, that have higher concern levels in the selected area of interest than the average for the ArcNet domain. We can tell this by looking at the bars going above the dotted line. We can also compare the concern level associated with each of the activities in the area to the concern level the activity exerts on average across the entire ArcNet domain, shown as gray bars. This shows us that the concern level for 22 out of 33 industrial activities is higher than average in the Arctic. By analyzing all of this, we see that the conservation concern level for the Bering Strait PAC is not only high but also diverse, hinting at the fact that it's a biodiversity hotspot. If we want to achieve long-term conservation goals, then we can see all the industrial activities that we should try to keep away from in the area, such as underwater oil and gas pipelines and production, which are coded as IOP and MLP here, and offshore mining and dredge fishing, among many others. Some activities, such as coastal infrastructure, which is coded as ICI, are hard to avoid even though they are associated with relatively high concern levels. In this case, good regulation can help keep effects as small as possible. Coming back to the bottom right panel, we can see the relative overall concern level by month, or ROCM. Interestingly, there's not much seasonal variation here. That means the area is important for biodiversity all year round. Now let's see if there's spatial variation. We can do this by selecting the SCP option at the bottom of the map here by looking at the significant concern level calculated for each planning unit map or the SCP map. We see very significant concern levels are the highest. This is shown with a color gradient from beige to dark red, with more intense red color signifying higher levels of concern. While the concern is fairly evenly distributed across the pack in this example, we can clearly see that the entire area stands out compared to the surrounding regions. To explore the SCP distribution in more depth, it can also be downloaded as a GeoTIFF file for further GIS analysis by clicking on the Download SCP button. Similarly, you can do this for the other indexes too, such as OCP and OIPP, by checking the respective boxes under the map. By clicking on the Download Assessment Results for OCCF and OCIA, you can download an Excel file of the results of the initial concern assessment for all features and activities. And finally, the Instant Report button allows you to download a consolidated Word document of the overview page. So far, we can see that achieving conservation objectives in this pack requires the establishment of certain measures. We can say this as we see a high level of overall concern, and there's a high number of activities with high concern levels. The area itself seems to be relatively uniform in terms of the concern. However, the entire area stands out compared to the surrounding regions. So let's see if there are already any protected areas in the pack. Click the Existing Protected Areas or EPA button just below the map. We see several protected zones on both sides of the strait, though most are coastal. That's encouraging, but to assess how well these existing areas protect high concern conservation features, we need to start the analysis by selecting existing protected areas on the landing page under the Spatial Query tab and analyze the conservation concerns for the Bering Sea against established measures. Now let's switch gears and explore the current industrial activities present in the pack. We can do this within the same overview page. We can click on the Analysis Type button and change it to Overall Industrial Pressure. Now, in the top right panel, we can see a graph that shows the relative overall industrial pressure by activity, or ROIPIA. The colored bars represent the pressure from different industrial activities in our area of interest, while the gray bars show the Arctic average for each of the same activities. What stands out here is that for some of the activities, the ROPIA is more than double the Arctic average. This is high and concerning, but it is also not as high as the level of conservation concern. This is because not all industrial activities are actually present. We can see this by clicking on the ArcNet domain in the upper right panel. Industries that are not present appear as gray bars. Also, when we look at the relative industrial activity amount for a given area of interest by planning units, or AAPU index in the bottom right panel, which is below 70%, it shows that the amount of industrial activities present in this area is 30% less than the average across the Arctic. So it is rather worrying to see such a high ROIPPU, which indicates the overall industrial pressure level or an area of interest compared to the whole ArcNet domain, even with relatively fewer activities. When looking at the ROIP for each month of the year, we can see that there isn't much seasonal variability except the overall industrial pressure is slightly lower during the winter months. By looking at the top CFs by ROPI list, we can see that 8 features have high ROPI levels of more than 75%. When hovering over the conservation feature code, we can see that many of them are seabird breeding colonies, which are not active during the winter. By clicking on the OIPP index layer and looking at the map, we can also see that most of this industrial pressure is concentrated on the western Russian side of the Bering Strait. If we click on the EPA index layer under the map, we can see that many of the red areas, which indicate high levels of overall industrial pressure, do not have existing protected areas. Coming back to the ROIPIA graph, we can see that only 11 of the 33 possible industrial activities in the area are present, and 4 of them are above the overall average as they are above the dotted line. You can also see that the sources of the highest industrial pressure on the biodiversity of the region comes from coastal infrastructure, tankers carrying oil and other petrochemicals, bottom trawling, cargo vessels, heavy fuel oil, pot and trap fishing, and long line fishing industrial activities. Let's try to understand the biodiversity composition of this pack to better interpret the overview. Click on the Selected Area Details button at the bottom of the map panel. Here we get a color-coded conservation concern table where we can see a list of conservation features with the selected area and columns of all the industrial activities assessed in Geranium. The table also contains columns with the coverage percentage and 3 indexes. Arranging the conservation features by ROCCF and ROIPCF, we can see that some conservation features, such as salt marshes and kelp forests, have high concern scores, but relatively low industrial pressure scores, which informs us that they are good candidates for conservation priority or are already protected. In contrast, features like the stellar sea lion critical habitat show both high concern and high pressure. This indicates that they are very susceptible to industrial activities while already being pressured by existing activities. Now let's investigate an industrial activity causing high pressure in an area by looking at the conservation concern table. Let's pick coastal infrastructure with the code ICI, which is a top concern in this region. We first sort the conservation features by level of concern from the coastal infrastructure industrial activity and can see at least 28 of 106 features. It is a source of significant concern all year round. Then click on ICI at the bottom of the column. This brings up 2 new buttons, ICI Details and ICI Overview. When you click on either of the buttons, an expert assessment panel shows up. This is a key feature of Geranium, which makes the rationale of Geranium concern and risk ratings transparent. By clicking on the ICI Overview button, you can see where ports and infrastructure are located and what the source of the data is. And clicking the ICI Details gives us a full breakdown of monthly concern levels for each conservation feature within the pack. Here we can also see that many of the features are coastal, and that's why ICI is a source of significant concern since it can lead to their destruction. As an example, the expansion of ports, such as the potential deepwater port, are potentially serious conservation issues in the area and motivate strong consideration of biodiversity in all planning and project stages from the start. If you want to explore the spatial distribution of these concerns for a specific conservation feature, you can go one step further. After selecting a specific conservation feature, the CF distribution amount map appears on the right. This is where the feature overlaps with industrial activity. A good example here is CF 1017 walrus haulouts, which are especially sensitive to coastal development. Now we can investigate whether we should be prepared for even higher pressures when we look into the future. For this, we need to go back to the home screen and change the epoch selection to 2030 to look at projections of industrial activities for 2030. We can see from the industrial pressure indexes in the lower right that the relative amounts of industrial activity, AAPU, in the area is expected to grow from 70 to 93%, while the relative overall industrial pressure, ROIPPU, raises from 158 to 202%. That's a big jump, especially since the projection of future activities within Geranium only includes infrastructure and mining. Geranium gives us a warning here. It helps us understand that this is an area where the consideration of planned industrial activities may motivate even stricter planning and regulation, urging us to be cautious of where, in which season, and how exactly specific activities should be carried out or not. To check on what we should prepare specifically, let's try narrowing it down. On the home page, select only ICI as the industrial activity. By clicking the All Conservation Features button at the bottom, you'll see a list of conservation features that may be impacted by core development, which helps plan where to avoid completely or mitigate infrastructure. Then go back to the home page and select just CF 2055 Stellar Sea Lion Critical Habitat as a conservation feature and click on the All Industrial Activities button at the bottom to view the different industrial activities that would affect this feature. If we look at the overview of only CF 2055 and all industrial activities, we see that there are at least 6 activities, namely cargo vessels, heavy fuel oil, bottom trawling, pot and trap fishing, longline fishing, purse seine fishing, and pelagic trawling, which are causing significant concern in the critical habitats for stellar sea lions. Therefore, more detailed data is needed to determine if the current protections are sufficient. Pac 5 in the Bering Strait is an area of high conservation importance and concern and faces broad risks from growing industrial pressures. While some industrial activities in the area may be unavoidable, Geranium helps us identify the biodiversity features most at risk, the activities causing the most pressure, and the places where protection or specific regulation efforts should be prioritized. Whether you are designing a marine protected area, reviewing shipping plans, or evaluating future infrastructure, Geranium is a powerful tool to guide discussions, further analysis, and plan conservation action. If this tutorial convinced you of Geranium's use, we encourage you to try it out yourself and in collaboration with others. Also, recommend it to people and processes where you think it might be useful. And finally, don't hesitate to get in touch if you have any questions.